Welcome everybody! Today we will complete our real-time strategy game, so it has all the basic features of a game like Age of Empires. We will add farming resources. They can be used to buy new units or buildings. Also, we will add a clickable map that you can use to quickly navigate over the playfield. We will add some basic movements for the computer player. And finally, we will create a scene that puts you immediately into a battle. But first, let's get rid of these borders. Creating a border with a cube is a very easy way to constrain the players to a certain space, but it doesn't look really natural. We can remove the mesh renderer and the players will still be constrained. But even then, it doesn't look like the natural situation where you have an island like this. It's just a straight line, and we would like to have a real natural looking island. And then we will want to constrain the people by not walking into the water. So we're gonna lower all the edges of the terrain, so the terrain will slowly move underwater, just like in a real island. We could use the collider of the water to check if we're hitting the water, but I found out it's more convenient to sample the height of the terrain to determine if we're hitting the water or not. Over here you can see the code. First we predict what the movement, what the position will be if we would move, and we use that virtual position to sample the height of the terrain and check if that height is less than or equal than 9. In that case we shouldn't move, but if it's above 9, then we should move the character. That way he will not move inside the water. Over here we can see the constraint in action. I can choose a position inside the water, but the characters just won't move into the water. They will just stay at the border and they don't get stuck or anything, so you can just choose another direction and they will move again. We could already select multiple units, but only the properties of one unit were displayed. So now I copied the properties info panel a few times, so we can display 4 units properties at once. Therefore I've changed this panel unit info to an array, and then we just loop through that array to set the info if we have multiple units selected. Over here you can see that loop. So if we have multiple units selected and there is still more units to display the properties for, then we set the unit info. If not, we just disable that panel so it won't be visible. So this is what it looks like when we select multiple units. You can see the properties of all the units over here. A strategy game should also contain some walls you can build to protect yourself. So let's implement that. I found this free model of a castle, and there is a wall over here that I would like to use to create own walls. So let's just unpack this prefab. And now we can drag out that single wall that we're interested in, and we can remove the rest, and then we can create a prefab out of it. But you see that this prefab has not the proper orientation. It's lying down, it should be standing up. If we now start building multiple of these walls by creating instances, the wall will be lying down. Over here you can see what would happen if we would create a wall by using that prefab. it's not properly orientated. So we can easily fix that by creating a parent object that has the right and then put the child in the right orientation. So if you take a look at the final prefab, you can see that there is a parent object now, and this wall object is inside the parent and is already properly rotated. So now if we create instances of this, then we will have a proper rotation of the walls. So in order to create the walls, we have this wall build script over here. It's just a single script in the scene. And we also connected the player input to that script by putting it in the same game object as the script. And this player input, this has a special action map for the build actions, has a place wall and a cancel build. And we use the left and right mouse button to place and cancel any walls. So these actions are used by that script over here, and you can see that in the script we have that prefab of a wall, and we also have a prefab of a wall plan. That's this one. It's exactly the same as the final wall, but has a different color. So before we can confirm the build, we can see what it would look like, and we still have the possibility to cancel the wall. And then you can see the part that is being created by this blue wall. So let's take a look at the wall build script then. Over here you can see how we draw walls. We take the start and end position, so as soon as you click the mouse, we are entering this method on place wall, and then we are storing the beginning position of the wall, and then we draw a wall from the begin position till the end position, so we can still move the mouse around and change the end position. And then this example wall is created at first, and then finally if we press the left mouse button again, the wall is completely built. So this wall consists of multiple of these prefabs of that wall part, depending on how much is necessary to reach the end. We got this wall length, it's 30. And that's the length of one single element of the wall. We just keep building them until we reach the end. And we set the proper rotation over here. We calculate the direction by using the end and start position of the wall. So this is what it looks like in the game. You can see that I can move the end position and the wall is properly rotated, and the amount of segments of the wall fits the end position. You can also see that the wall follows the terrain. Where the terrain is higher, the wall is also higher, and the start and end position of the wall segments are fitting each other. That's done by rotating all the single segments. For that we use simple trigonometry. You maybe know this from high school. If you want to calculate this angle, you need to take this side and that side and just take the tangent of them, and then you have the angle. So that's exactly what's happening over here. We take the height of the beginning and end, the difference of the terrain, and also the wall length, and then we calculate what angle is necessary to rotate the wall properly so that it just fits to the next segment. Also, you can see over here that we are returning the number of walls that was actually built. We use that for changing the amount of stone that the player has. Every segment of the wall costs 100 stone, and you can spent all the stone to build walls. After you've reached 0 stone, you can no longer build any walls anymore. So let's demonstrate that. Just create walls. You can see that the amount of stone is decreasing until it finally reaches 0. And now I can only draw 2 more segments. You can see that I cannot create any more. And now I cannot draw any segments anymore. So now we need to gather more resources to create more stone. But at the moment we cannot farm any stone yet. I've just made an example so you can farm wood, but the farming of stone is I'll leave up to you, but it's quite similar to creating the farming for the wood. In order to be able to farm trees, we need to keep track of which trees we have and what their position is. So I won't be using this paint trees option of the terrain editor, but I will create my own tree spawner. So it's over here. We have 5 prefabs of trees, and then we use this script to spawn them in this area. That's just the area of the island. Over here you can see the spawn script. We just create them at random positions, but we check if they are not too close to any objects. So that's any objects other than another tree or the terrain. So they won't overlap with buildings, for example. So then we can create a number of trees. We are creating 200 trees over here, and we can keep track of them in a list. So we have in this game script, we have a list where we have all the trees, so we know all their positions, and we can use that to farm. For the farming, I've downloaded this lovely character from Mixamo and put an axe and a log in her hands. So she will perform the farming. She is not a soldier, so we can use that. By the way, it's a female character, but by no means I intend to give females the role of the farming and the males the role of the fighting. It's just coincidence that this is more suitable. So yeah, this log is just removed, disabled in the beginning, and then when we gather a tree, it is enabled so we can show her walking back with the tree that she just has chopped. So if we take a look at the animator, she has a chop animation and the basic walking animation that's just the same as the soldiers have. And then for the script, we have different states for the lumberjack. She could be walking to a tree, or she could be walking back to the headquarters where she is also spawned from, then to bring back the tree that she just cut. Or she could be just cutting a tree. So that's the 3 states that the lumberjack has. And yeah, as soon as she wants to walk to another tree, first the closest tree to the headquarters is selected as a target, and as soon as it's chopped, this tree is removed from the scene and also from the list of trees that we have, so that we won't use that tree again. Over here you can see the code to cut the tree. We are chopping the tree, so we play this chop sound every time this animation of the chopping is ending, and the axe hits the tree again. And finally, when we are done chopping, we just make the tree rotate so it falls down, but we won't remove it yet. But then if the tree is completely falling down, we will remove it from the scene by changing the lumberjack state and then it will destroy this current tree and set the destination back to the headquarters. And we enable the lock, so you will see the lock in her hands. Over here you can see the farming in action. We spawned two farmers, two lumberjacks, and they start cutting trees. They move to the first tree that's available, and the animation is played, and also the sound of chopping is heard. And after a while we get into that state where the tree is falling, just rotating, and then removed from the scene. And then we see her walking back with the tree, with the lock, and then she selects another tree to chop. Now for the map, one easy thing would be to use a second camera that you're showing from high above, and then you have a live map that's just following everything in the scene. So that's very useful if you have a lot of things happening on the screen, but that's big performance costs to have a second camera drawn. So I don't use that over here, but instead I use a fixed picture of the terrain. So that's way less performing demanding. So in order to do that, I just change the view position to something like this, and then I took a screenshot of this, and then I have just a picture of the island, and that one I've loaded in the UI on the canvas over here. So that's the way to create a map. And then we want to show the position that we are on the map to have some orientation. For a real-time strategy game, it's very important to have a good map that you can easily use to navigate over the terrain, because the terrain is usually much bigger than the part that you're just viewing, but you need to very quickly switch between different positions to change for example, the destination of some of the soldiers and their movements. So over here we've also got the line renderer, and we have drawn 4 lines. So that's a list of 4 lines over here. Actually 5. I want to go back to the first position, but yeah, this is just a square right now, but we change these lines, these corners of the lines. We just calculate every time depending on how what we see on the screen. So you can see that over here I've added that to the unit selection script. Actually, it would be maybe better to have it in a separate script, but just for easy starting, I've just started to edit here, and I should still move it out to a separate class. But anyway, over here you can see update screen on map corners. So that's the corners of those lines, those white lines that you see. We just sample the position like we did before for the pointer of where the player should move to. We just use a screen point to array function, and then we do array cast to see where we hit then the terrain, and that's the position on the screen. So with those 4 positions, we know the world position of the area that we're currently watching, and then we can display that onto the screen with the 4 lines. So Over here you see that the line renderer points are updated. And then when we click the map, so we made this whole map into a button, so that oh, it's actually a bit misplaced, I see over here. We created it as a button, so we can click it and then we can decide what position we clicked. You can see that we use the onMapClick method in the unit selection class. So if we take a look at that, you can see that we again take the mouse position where we're clicking, and then we need to translate that to the proper position, the percentage that we are in the map. So let's say over here we are at 0% and over here at 100%. Then we know what position we can put this square, or where we can actually where we should place the camera. So you can see that over here. So we take the ratio, we say the mouse position, we have some fixed values here because I've just calculated how large this button is, and we use those values to determine the position. We could make this more dynamic, of course, by measuring the current button, but it's always a fixed size in my case, so I won't change it, resize it or anything. So this will do for now. And then we determine the position. You can see this 1500 over here, that's just the size of the whole map. So if we are at, for example, 50%, we are at 750 units. You can see that a bit over here. So these coordinates, 750 is a bit in the center of the map. And then we just set the camera position to that position. Over here we can see the result. You see the lines. They are representing the actually position that we are seeing over here. You see that this is not a square because we have a bit of perspective. If we do like this, you can see that it's even more. We can see more far away, and this area becomes like a triangle. If we watch it completely top down, you can see that it's a real square. And if you zoom in or out, you can see that it's getting bigger or smaller. And even if you rotate the map, or if you rotate the camera, you can see that the square is also moving along. So this works quite well. And also if you click on the map, you will move to that position immediately. So we do that by just translating the ratio that we are in the map that we are clicking. You can now spawn armies by clicking these buttons. If you do so, we will call a method over here on button spawn pikeman click, and this will finally create an army by calling this method in the barracks, the spawn new army, and it will spawn an army of the proper type. It will also set a timer because we want to have a certain time before we will actually spawn that unit. It takes some time to create it, and during that time it's created, we have this progress bar, and we just increase it. We have a progress bar that's showing the army that's been spawned, and also one progress bar on the barracks itself to indicate when the unit will be spawned. We can use that also on the enemy base, so that you can also see when the enemy will spawn a new unit. Over here we increase the value of that progress. You can see that over here there is this this progress, and what we're actually doing is something like this. You can see that it's slowly filling with this yellow color, and then when it's completely filled, this unit will be spawned. So over here you can see that if the timer of the spawning is finished, we will just disable those progress bars and create a new army by instantiating it at the spawn position of the barracks. So it looks like this. You can click any of these buttons and then you can see the progress bar of the barracks and also the progress of that button over here. It's being increased, and finally when it's done we will see the new army appear. It's over here, just at the same spot as the existing army. We created one army already at the beginning, so we start with something just to get started right away. But you can change that if you want. It's over here in the startup method of the barrack script. You can see that we have spawned a new army, and we immediately set the timer to very small value so that it actually immediately will show up. The barracks of the red army spawn computer players. We have different prefabs for the blue and the red army, and you can see that the red army contains a script, Army AI, especially for the computer players, so these players get moved by the computer. We take a look at the Army AI script. It should be extended a bit more to make it really a good AI script, but we have some basic elements already in here. These computer player can explore the terrain, he can attack the enemy headquarters, or he can defend his own headquarters. They also have a number of destinations that he can have, for example, to control a certain area of the map. And yeah, this code just sets the destinations for the enemy, and if the destination is some object of the blue player, then he starts also to attack it. So it's a very simple script at the moment, but it's already enough to have some basic computer playing actions. Over here you can see the AI player in action. This unit is already spawned in the beginning of the game, and it's now doing something. It's moving, and we can observe it. Let's just find it in our scene. It's over here, so we can change the inspector to debug to see the Army AI script values, and we can see that it's now defending its own headquarters, and it has 2 patrol destinations, so it's actually moving back and forth between these 2 destinations in order to defend the headquarters. And finally we're going to create just a demo scene to get you into the game quickly. I've added this play input also to the game script, and we have here the game actions. If we open the player input, you can see this action map over here. It's just one thing that it does. It just can create a demo 1 by if you press the 1 key. So then you enter this this method on the game script, and that just creates one demo. In this this demo script, I've added a few useful methods. We can create units in a circle, multiple units, and they will just circle one object, for example the headquarters. So we can just immediately siege the headquarters of the enemy with that. Also a method to select a random unit, just to make it a bit more random. So you can create your own demos if you want, and put them under other keys, for example. So just let's take a look at what my demo scene looks like. I press the button 1, and now we can see that units are spawned into So we can see that the game works with a decent amount of the units, and yeah, you can see that now the headquarters is being destroyed. The red army is stronger, it's just stronger than the blue one, and will start to attack the headquarters of the blue army. Will start to create damage and finally destroy the enemy base. So that's it for the demo. So that's it for today's video. I think we covered most of the aspects of creating a real-time strategy game. The main thing to do now is to enhance the farming of more different materials, and creating more units and more animations, so to make it look even better and like a professional game. But yeah, you got all the basics now to create something really nice. Thank you for watching, and see you in the next video.